We're going to review parallel iterations a little bit. Specifically, I'm just going to talk about map2 a tiny bit, and then we're going to review a little bit of what we did with Pmap, and then we will move on from there to discuss Pmap further, finish up the slides from last time, and then from there we will talk about looping variants. Okay, I actually feel fairly confident that we will get through all of this, but if not, please do review the rest of the looping variant slides. Okay, so map2 works like this, right? So it's just like map, where we feed it a vector and then we feed it a function after that. The only difference is that in this case, we're now feeding it two vectors, and it's going to loop over both of those things at the same time. Okay, so here I'm feeding it some orange vector and some blue vector, and then I pass it some function. This yellow here is additional arguments to the function. So like na.rm equals true, right, to remove missing data. And then what it would do is it would apply whatever that function is to the first element of each vector, and then pass the additional arguments as well. Then same thing for the second element, third element, etc. My cat's going crazy. Both of them actually. Okay, so we applied this like this, where we have we set some conditions, so like an n and a mu, and then we're going to use map2 to loop over both n and mu, and then apply some function. So in this case, we're sampling from a random normal distribution with whatever the dot x is, and so this is the n, and then with a mean of whatever the dot y is, so this one, okay? This returns a list because we're using map, right, map2, and so we have to unnest that column to end up getting a nice data frame like this, okay? Another example, we talked about creating plots using this. So here we had this newspaper data, right? And we have different newspapers, and then we nested the data by newspaper. And then we produced all the plots, right? And so part of what we did here is we changed the title of the plot at the same time. So we're saying mutate to create a new variable where the variable is called plot, and we're going to map to, so we're going to loop through both data and newspaper. So I'll go back here. I'm going to loop through the data first, and then the newspaper second. And then I'm going to, when I do ggplot, I'm going to say ggplot.x, right? .x is the data. And then here's all of my plotting code. And then for my title, I'm just saying glue Pulitzer Prize winners .y. Okay, and that's going to insert the newspaper name. So our data frame now looks like this. We have all of this list of GG objects, and then we can look at a first couple of them, and you see USA Today, Wall Street Journal, etc. Okay. Pmap works sort of similarly to map2, but the main difference is that it doesn't know how many vectors you're going to be looping through. And so what you have to do is pass it a list of vectors, and then it will loop through all of them. This is wonderful. Okay, so we have this example. Let's go here, where we did something like this. So now we're doing the same sort of thing, but we have an n, a mu, and a standard deviation, right? So this is that full conditions thing. Looks like this, right? So we have 3 different columns now, and we're looping through all of them. So if I say list, I pass each of those. There's a couple of different ways I could do this, but if I want to use the tilde, I can use the tilde just like with map and map2, but instead of saying .x and .y, we don't know how many things we're looping through. It might be 5 things, it might be 6 things, or in this case, it's 3 things. So we just use an index to refer to them. So n is equal to .1. That's going to loop through this thing. Mean is equal to .2, and standard deviation is .3. Okay. So then, as it loops through, it's going to simulate from a random normal distribution the first time with an n of -2 or n of 5, mean of -2, and standard deviation of 1. Then the second time it's going to loop through with an n of 10, mean of -2, standard deviation of 1, etc. And it's going to go all the way through this data frame, okay? This 10,710 different conditions. And it actually works quite quickly, okay? Just like before, we can make this a list column. So now I'm just doing it like this, list n mu sd, because I'm doing it through the data frame. And then when I call this R norm because it's Pmap, not Pmap double or whatever, then I end up with this list column here, and then I can just unnest that again. Okay, so that was as far as we got, and then I was going to have you replicate with nest by. So that's a quick review. Any questions on that we covered last time? Yep, Meg.
Sorry, I feel like this is kind of a dumb question, but there's the ... 1.
Mm-hmm.
Why are there 2 dots?
Yeah, that's a good question, actually. I think the answer is just it's something they did differently to distinguish when you're indexing versus just doing .x and .y. So like .x and .y are the normal ones, and then I can't remember exactly what the justification was. There was a blog post about it at one point, but it's basically like just something additional to distinguish it from like .x and .y.
Okay, thank you.
Yeah. Okay. Any other questions? All right. Drive me crazy. Okay. So if we wanted to replicate this with nest by, that would be using a row-wise operation, right? So this is how we would do this here. We would take full conditions, and we would pipe that to row-wise, and that's going to fundamentally change the way that the data frame is working, right? So now every operation is going to happen by row. So if the output from that operation is anything other than a single value, we need to wrap that output in list, okay? So here, I'm saying mutate, create an object called sim, where I'm going to have an output that's a list, and I'm going to use R norm with this n, this mu, and this standard deviation, okay? And then when it does that, that's going to end up giving me the exact same results that I got before with map or with Pmap. So in some ways, this is a little bit easier, but as I mentioned before, Pmap is a bit more general, okay? Because row-wise is obviously only going to work within a data frame. Okay. Plotting. So we're going to move on to plotting now. And before we get started here, what I'd like you to do is just actually go back to your code and say library 538, and then grab Pulitzer and just run this code so that you have this sort of data frame. Okay? So I'll give you a minute or so to do that as I again try to fix my thing. What's going on? Okay. Hopefully everybody has that. And now we're going to create a column to represent a label. Okay, so what we're going to do here is we're going to add a caption to our plots that states the number of Pulitzer Prize winners across years. Okay, so there's many ways we can do this. One of the easiest ways, I think, is to first create a column in your data set that has the actual label that you want. Okay, so here I'm loading this English library. You don't have to do this if you don't want to. But I'm taking Pulitzer and passing it to mutate. And I'm creating a new column called label, where I'm going to glue together the total. So back here, tote, right? And I'm moving this to as.english. So this is going to be, oops. So this is going to be the word 2. This is going to be the word 50, etc. Okay? And then I'm calling string to title on that from stringer, which will put it in title case. And then I'm just saying total Pulitzer Prize awards. And so what we end up getting is something like this. Okay, so I'm just selecting from Pulitzer here the newspaper and the label. Okay, and then I end up with my newspaper and my label. So if I want to produce one plot, I could do something like this, right? So I'm creating an object here called temp. And I have Pulitzer. I'm going to pass that to filter and say where the newspaper is equal to the Wall Street Journal. Then I'm going to create my plot where I'm just using temp. Okay. And then on my title, I'm going to have Pulitzer Prize winners, Wall Street Journal. But then for my caption, I'm going to say the label, whatever the label is. And notice in this case, I'm using unique. The way we'll do it in a minute, we won't have to do that. But I'm using unique because I have 2 labels there, right? And so I don't want the labels sort of plotted on top of each other. So you can go ahead and just copy this code if you want. And then when you run it, it will look like this. Okay, so we have Pulitzer Prize winners, Wall Street Journal. Here's the 2 years. And then we have 50 total Pulitzer awards. Okay, so if we want to produce all plots, we're going to nest first. And notice this time, I'm going to say group by newspaper and label. Okay, so that is why I won't have to use that unique, because now I just have a single label for each newspaper. Okay. And then why don't you take a minute and see, it's on the next slide, obviously, I just jumped to it. But see if you can modify this code, basically, that you have here, to produce that plot, create a new column in your data set that is that plot for every newspaper. Okay? Give you a couple minutes. Okay. Hopefully you did something like this. Okay, I have Pulitzers. All of this part is just what we had before, but now I'm going to create a new column where I'm calling it plots, and I'm going to pmap this list. Okay, so this is part of what I was mentioning that is different about pmap from the other functions, is that the first argument is going to be a list of the vectors that you want to loop through. Okay, so in this case, I'm looping through 3 vectors: the newspaper, which is this one, the label, which is this one, and then the actual data itself. Okay, and you can put these in whatever order you want, but then you're going to refer to those things if you're using the tilde, right? You're going to refer to those things through their location here. So I'm saying ggplot ... 3 to refer to the data, right? And then we come down here to the title. I'm gluing Pulitzer Prize winners ... 1. And again, you could use paste or paste 0 or whatever there if you wanted to not use glue. And then on the caption, I'm just saying is equal to ... 2. Okay, so that's going to just equal whatever this is. Questions on that? All right. So we can look at a couple of these plots just like this, right? So we can say final plots, plots 1. Here's USA Today, and it says 2 total Pulitzer Awards, right? And then final plots, plot 2. This is Wall Street Journal, and it says 50 total Pulitzer Awards. So you can see this one goes to 20, so that means this one's 30, right? Final plots 3, New York Times, 117, etc. Okay, let's try now to replicate the same thing, but with nest by. Okay. got you back. Oh, finally. God. All right. So give me, now that I can get some feedback, give me an emoji like thumbs up, thumbs down on how successful you were with that. Okay. All right, so some mixed things there. This is all right, like quite difficult and very new. So if you are having challenges, don't feel bad about it. All right, this is why we're practicing. Okay, this is how I would do it with row wise. So I have Pulitzers. I said ungroup because it might have been grouped. I don't know if it was grouped or not. But then I'm going to nest by newspaper and label. Okay, so what that's going to do is it's going to create that. It's going to do just like we did before. It's going to group by newspaper and label, and then it's going to create a list column. But the only difference is it's also going to turn it into a row-wise data frame. Okay, then we're going to mutate with plots where the output is going to be not a single value, so we have to wrap it in list. And then we're going to say ggplot data, and then we just put newspaper here and label here, and otherwise it's the same. Okay? So then it looks like this. You can see we have a list over here. It's running off the screen, but all right. Last thing for this set of slides. Let's say we want to save all the plots. Okay, so we have to iterate across at least two things: the file path and the names, and the plots themselves. Right. So we have to create some file paths, and then we have the plots themselves. And so we have to iterate across both of those things so we can say, here's the plot, save it to this path, right? So we can do this with the map family, like map2, but instead we'll use a different function generally, which we're going to talk about in just a little bit. We'll just forget about that. There is also a nest by solution that we could use, and that's what I'm going to walk through right now. I'm not going to have you do this. We'll just do it, okay? So if we were going to do this, if we were going to save these plots using a nest by solution, one thing we could do is first create a vector of all of the file paths. Okay, so the way I typically tend to do this is I'll create a directory in my R project for plots, and sometimes it's already there, but then other times I want to create a directory within that plots directory. So in this case, I'm going to create a directory just for the Pulitzer plots. Okay, and then you're going to loop through those file paths and the plots and save each one. Okay, so it'll go file path and plot all the way through. Okay, so here's how we would do this, and you can feel free to follow along. You don't have to if you don't want to, but I'm using FS, which is the same package that we used when we talked about batch loading. You could use base functions too, but FS is generally nicer in terms of defaults and things. So I'm saying dir create here plots Pulitzers. So I'm saying from here, my R project created a folder called plots, and inside that folder, create a folder called Pulitzers. Note that this will work whether plots already exist or not. Okay, so if plots works, it'll just create Pulitzers inside of that. If plots doesn't exist, it will first create the plots folder and then create the Pulitzer folder within that. Okay. Then I'm going to create my file paths. So I'm first creating something that I'm calling just files, where I'm saying, okay, here's my final plot newspaper, right? The name of the newspaper. And I'm going to string replace all. I'm going to find every instance of a space, and I'm going to replace it with a dash. Okay, that's what that is saying right there. String replace all, find the spaces and replace them with dashes. Okay, and then for the newspaper, I'm also wrapping it in to lower, which is just going to change everything to lowercase. So that's going to give me just the file names that I want. Okay, and then finally, I'm going to create the paths by saying here plots Pulitzer. So that's the directory I'm going to save them to. And then I'm going to glue or paste 0, whatever, files, this thing I just created here, .png. Okay, so that's going to create my whole file path, and then it's going to have the different name of each newspaper.png, where I've made those names lowercase and I've replaced all the spaces with dashes. Does that make sense? Okay, so now I have my vector of paths, and what I could do is actually just add that vector of paths to my data frame. Okay, so I'm saying final plots, I do have to ungroup it because it's a row-wise data frame. And so if I tried to actually add this without ungrouping, what it would do is it would think that I was trying to add, however long this is, 50, I guess, 50 paths to the first row, and then 50 paths to the second row, right? So I have to ungroup it first, and then I'm creating a new column here that I'm calling paths, or path, which is here, and then that's going to be the paths that I just created. And then I'm going to just select plots and path. Notice the path is so big here that it's just being cut off, but here's all our plots, and then the path is there. Okay. Now I can turn this back into a row-wise data frame to actually do the saving. So I think, personally, I think this is kind of a little bit weird, and it's actually more clear to me to do this through looping rather than this row-wise approach, but I kind of wanted to show you anyway because it is an option. Okay, so I have final plots, ungroup, mutate, paths. That's all that I did previously, but now I'm going to pass that to row-wise. And then I'm going to say summarize. And then my summary function I'm going to pass it is actually ggsave, where I'm passing it the path and then the plots. And then this is just additional information that I want to pass to ggsave. Okay, but these are the two things that I'm basically looping through, that I'm applying row-wise operations to. Okay, and then I get, as a return, I get a tibble of 50 by 0. Okay, does that sort of make sense why that works? Questions on that? It's a little bit strange, but it is a pretty powerful approach still.
I have a question.
Yep.
I just tried to run the code for saving and I got an error message and it said, did you mean, and then putting list before ggsave?
You ran it just like this?
Mm-hmm.
You had summarize and not mutate?
Yep.
I'm not sure why that would be. It shouldn't be. Did it actually save? Or did it actually error out?
Everything was working until that point, and then I just got that error, but I'm checking in the plots and that all, it only saved one. So.
Okay.
I don't know.
I'm not sure either. It's hard to know without walking through the code with you, but this should work generally. It could be a version thing because all the row-wise stuff is pretty new too.
That might be it then.
All right, so wrapping up here on parallel iterations, they really increase the things you can do, right? Increases the flexibility that you have. Looping through two things at a time is pretty common. You can use map2 or you could use Pmap for that. Most of the time you probably use map2 because it's a little more straightforward. That's the reason why they created map and map2, is because those are sort of the most common, looping through a single vector or looping through two vectors at the same time. More than that, you got to use Pmap, or you could use a for loop or something like that. Okay. So if you're using the nest-by approach, that's pretty much always going to give you the same results that you get from group by nest, mutate, map. So it's often a little bit less code. You also can avoid things like the .1 or the .x or whatever. The biggest caveat there is that it has to be in a data frame, which means working with list columns, which is fine. But sometimes, especially when you get to more of the programmatic side of things, you don't really want to always be working in a data frame, right? And so you just want to loop through a vector and do something. So that's why I think the map family is better generally. Okay, so that's basically what that says. Okay, so we're going to move on now to looping variants for the last 45 minutes here or so. Any questions on any of the parallel iteration stuff though before I move on? Okay, I do want to just emphasize that looping as a whole is a big, difficult concept, right? It's a hard thing to get your head around for sure. And so I've tried to show a whole bunch of different examples of different ways that you might use looping. Sometimes those examples maybe don't work for you because it's not something that you're familiar with, and that's fine. The main thing is that I'm trying to get you to understand that a loop is iterating through a vector, right? And so there's all sorts of reasons that you would want to do that. Hopefully, at least some of this is hitting home. Part of the reason I'm sort of summarizing like this is because I'm going to move on to looping variance here in a second, but then after this, after today's lecture, we're going to move on from looping and we're going to be talking about functions. We're still going to be using loops a lot because we're going to write functions and then we'll loop those functions through things, but we're not going to be, I'm not going to be lecturing on loops anymore after today for the term, okay? So as you're working on your homework and things like that, please do let me know if you're having trouble, okay? If there are things that are looking unfamiliar or whatever, please just reach out. Okay, looping variance. So I want to talk about walk. That's the first and probably in my mind the most important among these. Walk and safely are probably the most important. So we'll talk about walk first, and then I'll fairly briefly talk about modify, which is very, very similar to map. And then we'll talk about safely, which is really different, but very helpful. And then finally, we'll talk about reduce, which is also really different. And I'm surprised at how often I actually use reduce, but then it's one of those ones where I find use cases for it a lot, and then I come to write the slides and I have a difficult time figuring out a realistic use case. So the examples there might not be great, but hopefully you get the idea. Okay, so know when to use walk instead of map. So walk is very similar to map, but there's one main difference, okay, and why it might be useful. Understand the similarities and differences between map and modify, and then with safely, we're mostly going to talk about it in terms of diagnosing errors, okay? And then reduce is mostly for collapsing or reducing lists. Okay, let's go back to our plotting example from, well, this class. So go ahead and load these libraries. You probably have most of them loaded already. You don't have to worry about English if you don't want to. And then this is just our prep for our data, which hopefully you've already done. You can copy that code if not. And then produce our plots. Okay, so we just walked through an example of saving all of these plots using this nest by approach, okay? I think it's a little bit awkward using that because you're adding paths to a data frame and then you're like summarizing with a save and it just feels weird. So instead we're going to do it again, but we're going to use the walk family, okay? So what I'd like you to do, well, I'll explain this first apparently. So walk it works just like map, okay? It works exactly the same as map. The only thing that's different is it's not going to print anything to the screen at all, okay? So that seems weird, but there are many things that are technically referred to as side effects, okay? So a side effect is anything that actually alters the world, okay? So if you are printing something to the screen, that's actually technically a side effect because it's something sort of outside of the function itself. The function is doing all these operations, but the print statement is sort of like a side effect. Saving plots installing packages, all of those things are side effects, okay? When there are many, many times when you want to run an operation for its side effect, okay? So like creating a plot or saving something to disk. And walk is the function that you should use when you want to apply that function for its side effect. If you know, if that's confusing, that is expected, right? It's weird to think of the thing that you're trying to do as a side effect, but it has to do with this whole thing called purity with functions. And we'll talk about that a little bit coming up, okay? But the main thing is if you're trying to do something and you just want it to do that thing, then walk is going to be better, okay? This is the more practical take home for this. If you're using R Markdown and you're doing something like saving a bunch of files to your disk, if you render that R Markdown, you'll get some weird output in your actual rendered HTML file. Whereas if you use walk, you will not. Okay, so this is what I'd like you to do to sort of see this real quick. Create a new R Markdown document. If you're working with notes right now and you've been doing that in an R Markdown document, great, just go with that. If not, then paste what you already have into an R Markdown document. And then what I'd like you to do is, well, I think, yeah, and then we'll walk through that. Okay, so I'm going to give you just 2 minutes to get set up with R Markdown. So again, copy the code that we've had earlier in the slides. So you should have, you know, a data frame that has all of the plots in it. Okay, hopefully you're set up now. And now we're going to create the directory just like we did before. So you can copy that code, create the file paths. And again, you can create them however you want, but you can just copy this code if you'd like as well. Okay. And then use a map family to try to save all of your plots. So not the nest by, right? After you've done this, you have your directory created, and now you have newspapers and paths, right? So paths uses newspapers. So really you want this paths thing. Then you're going to loop through your plots and your paths and save them all. Try to do that with one of the map family. Okay, so you're going to loop through paths, the thing on the previous slide, and final plots to save all of those plots. Okay, once you get that code working, click knit and look at your HTML output and see what it looks like. Okay. Okay, would somebody please share, what did you see when you used map? What did the HTML output end up looking like? Did nobody get done? Did I not give you enough time?
Yeah, I think it runs. It goes along printing the numbers and just telling you that it's doing this. It's saving the plots as you go along, and that also
Yes.
gets printed in your
Yes.
HTML.
That's exactly right. So what you should have seen is when you render the HTML output, you'll see like a 1, 2, 3, 4, 5, 6 in little brackets as it's going through. Okay, and most of the time you're not going to want something like that in your actual HTML output. So you could do something like include equals false or whatever, but maybe you want to echo all the rest of that code and you just don't want to do that one, right? So instead, you will use walk, okay? So just like map, walk has walk2 and pwalk, okay? But what I'd like you to do now, and I'm just going to do 1 minute because it's actually very quick, just swap out your map call for walk and see what the rendered HTML looks like then. Okay, what do you notice now?
I still get some sort of output, but now it just says saving 7x5 in image.
That's because, yeah, so that's a message
Okay.
versus the 1, 2, 3. So yeah. You will probably still have to omit the messages, but the actual like iterating history should be gone. I forgot about that. Okay, so this is how I would have done it, right? Walk to paths and then final plots, GG save, and then additional arguments to GG save. You could also do tilde GG save with parentheses and then, you know, .x and .y. Okay, so that's really all there is to walk. It's very much like map. It works exactly the same way. It's just going to not return the output. Okay, so specifically for saving plots, that tends to be where I use it most, but there's other things similar to that that I might want to use it for. Okay, so for example, another very common use case is I've created those plots just like that, but now I actually want to render them, like I want to print them all to the screen in my HTML document. And you could try this right now if you wanted to, but it would be a lot of plots. But you could say walk, just walk, not walk to, through the plots, right? The final plots. So you'd say walk, final plots, and then say print. And what it would do is it would go through and print each plot, but it won't print it with the iteration history in it. So it won't say like 1, and then there's the plot, and then 2, and then there's the plot, and then 3, and then there's the plot, right? Okay. Any questions on that? Okay, so it's very, very similar to map, but just the output is a teeny bit different. Modify is also just like map, except that it's always going to return the type that it iterated through. So if you iterate through a data frame, it will return a data frame. If you iterate through an atomic vector of type double, it will return an atomic vector of type double. Okay, that's really the only difference. So here's an example, right? I'm mapping through empty cars and I'm saying as dot numeric scale x. Okay, so what this is going to do is it's going to go through each column, each dot x column. It's going to scale it, and then it's going to make it as dot numeric, because by default scale will actually return a matrix, a one column matrix. With modify, I do this exact same code and it returns the actual data frame. Okay, so this looks exactly like it did before, because it's just always going to return that type. Okay, so the modify hopefully keys you into that you are modifying the thing that you are iterating through. So you're not, I mean, you are creating something new, but it's modifying it, so you're just changing whatever it is. Okay, here's another example where I say map to letters 1 through 3 and letters 1 through 3. So these are uppercase and lowercase, and I say paste 0. Because I'm using map, it is of course going to return a list, right? In this case, I'm saying modify 2. This is a character vector. This is a character vector. So when I say the function that I want it to apply, paste 0, it's going to return a character vector. Okay, so you could be more explicit with this and say map to underscore CHR, and you would get this same output, right? But modify is just kind of nice because you can sort of always ensure that the output is the same type that you input. Okay, that's really all there is to modify. Very complicated, right? Any questions on that? All right, safely is a bit more complicated, but it's quite useful. Okay, so safely is meant for when you're iterating through something and it's possible that there's going to be errors. And in this case, like let's say you have some big thing that you're iterating through, like 1,000 cases or whatever. If you have one single error in any of those iterations, your whole loop is going to break, regardless of if 999 of them worked. Okay, and so safely stops that behavior. What it will do is it will go in, and each time it iterates, it will return a list of length 2. It will return the output and error. Okay, so each time that list, one of those two things is going to be null. Either it's going to have an error or it's going to have the output. Okay, but it won't have both. So this is most often because you want to, well, maybe not most often, but it's very often because you want to return the output that doesn't have errors. But it's also really helpful for diagnosing where errors are occurring and why. Okay, so we'll walk through an example here, and if you could follow along, I think it would be helpful for you. Okay, so here I'm creating an object called byCil, where I'm saying mpg group by cil and then nest. Okay, so here's my cylinders 4, 6, 8, and 5. Okay, and then here's my data for them. So let's say I wanted to fit a model for each data. Okay, I could say byCil mutate mod is equal to map data. So I'm going to loop through the data, and I'm going to apply this model, right, where highway miles per gallon is predicted by engine displacement and drive. Okay, and I say data equals .x. And I get this error in return that says there's a problem with mutate and the input mod. Okay, so for this specific thing I'm trying to create. And then it tells me the form of it, and then it says the error occurred in group 2 cil equals 5. Okay, well, in this case, the error message is very helpful in telling me that it's occurring with the fifth one. But in most cases, it's not quite so straightforward, especially if you have a bigger list that you're iterating through, and there might be 17 out of the 50 that you're iterating through that have errors. Okay, so what we can do is we can create a safe function. Okay, so this is how safely works. We're going to first create a function, which I'm calling safe_lm. Okay, you could call it whatever you want to call it though. Anything will work. And then you just call safely on that function on lm. Okay, and the thing that is fairly impressive about this function is you can create safe functions for any function that exists, including ones that you wrote in your script just before. Okay, so they could be custom functions, it won't matter. You can always create safe versions of those functions using safely. Okay, so now when I iterate through, rather than applying lm as I did before, I'm going to apply this safe_lm function. Okay, so I first create this safe version of the function that I want to apply, and then I loop that version through when I do my iterating. Okay, and so I'm calling this safe models. I loop through, and everything works, right? It loops all the way through, everything works. Notice this safe mod object that I'm creating here. Each time it returns, it's a list of length 2. Okay, so as I mentioned before, it's a list of length 2 where one element of that list is the result, if it's there, and the other element is the error, if it's there. So one of those two will always be null, and the other one will have the error or the result. Okay, so if we look at the first one, safe models, safe mod 1, right, double bracket 1 because we're indexing the list, we see it is itself a list. We have result and we have error. So the first one has the result in it. The fourth one, which is for cylinder 5, has an error in it, and it has no result. Okay, so if all we really want to do is return the cases where we have the results, then we're most of the way there already. The only thing we might want to do is now subset our data frame to only those that have actual valid results. Okay, but I often use it for debugging. So why is it failing at this specific place? Okay, so regardless of if I just want the results or I'm debugging, I almost always do this part first, where I create a new vector that tells me whether that row of the data frame had an error or had the result. Okay, so this is how I would do this. And there are probably other ways. Well, I know there are other ways, but this makes some sense to me. And I'll walk through it because I think it is still rather complicated. All right. So I'm doing map LGL because I'm returning a logical vector. You could return other types of vectors, of course. But I'm going to loop through safe mod. Okay. Each time I loop through this, I'm going to be accessing a list that looks like this, right? So every time I'm getting a list in return. So what I'm going to do is say is.null, okay, is.null for .x $error. Okay, so $sign is going to give me the thing that is named error. Okay, so if I come back here, I'm saying, is this element of the list null? So for this one, it would return true. For this one, it would return false. Okay, and then I use this exclamation point here to flip those. Okay, so now I'm getting falses where there is not an error, and true where there is an error. Okay, so that's the part that's a little bit confusing. It's fairly straightforward, I think, to understand that you're looking to see if it's null. But really, that's usually the opposite of what we want. We want, where are the errors? Okay. If you wanted what I was talking about before, where you just wanted to filter your data frame to just the valid results, then you would just, omit the exclamation point there, and then you could filter on error, and you'd be good. Okay, does that make sense? Okay. Now, so here's that mutate, right? This is a logical, right? False, 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 true. So I can then just pass filter to error, and it will return the rows that are true. Okay. Then I'm going to say select sil and data and unnest that data. So basically, I'm selecting just this row, and I'm saying give me this column and just the data, and then unnest the data. Okay, and that gives me this. Now, if I think back to my model that I used, I had displ, which is here, and drv, which is here. And you can see for both of those things, they're constant. There's no variance in them whatsoever. So the relation between them and the outcome can't be estimated. And so that's why I'm getting an error. Okay, so that means in this case that I really can't do much with it. So instead, I'm just going to pull the results that worked. Okay, so this is just another way of doing it. You could do it like I just showed, but if you just want to pull the results, so you could just pull the error also, but if I wanted to just pull the results, I could create a new column called results, and I'm going to map through safe mod and pull the result, right? I could again do tilde.x $result, and that would work as well. This is just another way with map to pull named elements of a list. Okay, and so you can see we get lm, 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 and then of course null there. Does that make sense? Questions on that? Okay. So we can now broom tidy or whatever, right? So tidy the results, whatever. Okay, when else might we use this? Any sort of web scraping. This is like a super, super common use for Safely because websites change, right? So maybe you have a script that's set up to go to some web page and pull some data, right? If the URLs don't work, you don't want to be going out to 2,000 different pages on the web and then have your entire loop fail because one of them changed, right? Since you last ran the script. So instead, you can wrap that in Safely. So here's an example, right? And I realize we haven't talked about web scraping or at all. This is just an example. If it doesn't make total sense, that's fine. The idea is to get like conceptual understanding of what we're doing here, right? So here I have some links. I'm passing them as a list. And here's Wikipedia, FC Barcelona, no such page, right? And then Rome. Okay, so these two are real pages, obviously. This one is not. Okay, so if I did something like this, where I say map through links, I would probably want to do something like this. This is more web scraping stuff, but would make it so that it's not hitting Wikipedia 8 million times in a row. So I would have it sleep. So I would say take a break each time as you're iterating so that you're not just like pounding this website, because that's bad manners and can actually get you banned from websites and things. So you don't want to do that. So we say syssleep 0.1. So it's just going to take a little teeny break each time it goes through. And then I'm going to say read HTML for .x. So it's going to say read HTML for this one, and then for this one, and then for this one. Okay. And if I try to do that on pages, I'll get error, failed to connect to no such page port, right? Because it doesn't exist. So that's a bummer, especially if I have, again, like 500 pages that I'm going to, right? Because I don't want my entire loop to break just because one of them breaks. So instead, yeah, so this is just reiterating what I'm saying. I can use Safely, okay? So what I would do here is I would say safe read HTML, Safely for read HTML. And then this is the exact same code, but now I'm saying safe read HTML.x instead. And you can see I have a list of 3. Each of them are a list of 2. So this one has a result. This one has null for the result. And this is the error, failed to connect to no such page. And then this one is has a result. Okay. So then from there, you know, in the real world, we would probably want to subset our list to just our failed pages and go and see, maybe actually go visit those pages and see why they're not working. Maybe the website got redirected and now it's at some different page. Maybe it just doesn't exist at all anymore. Maybe the contents of the page really changed, whatever. Okay, so we could do that like this. Again, same sort of thing as I showed before. This is just doing it sort of outside of the data frame approach. So I'm creating a logical vector here where I'm saying where it's not null for the error. Okay, this is going to be a logical vector. And then I have my links, and I'm going to subset it with errors. Okay, so this is giving me a list in return that has just the errors. So those would be all the links for all the errors. Okay, and then if we wanted to, again, just like we did before, we could loop through all of those and pull out just the results if we wanted to. Okay, so safely, I think, is a super powerful function, especially if you are doing web scraping sort of stuff, but it's also really useful just for diagnosing errors when you're running these big loops in particular. Okay. Questions on that? The only thing about safely is that it's a little bit challenging because it always returns a list also. So then you end up with, like, pretty much by definition, you're going to end up with a nested list, a list within a list, right? Which can be challenging sometimes. Okay. Last function that we'll talk about is called reduce. And reduce, with map, right, with all of the map family of functions, they always return a vector that is the same length as the vector that we fed it, right? So if you give it a vector of length 5, you get a vector of length 5 in return. If you feed it a vector of length 200, you get a vector of length 200 in return, right? Reduce will collapse that vector to a single element. Okay, so this is really useful if you want to do something like compute the cumulative sum or something, right? So as you're iterating through, you're saying the sum, and you want to add the previous result to this next iteration, right? Reduce will allow you to do that. So here's an example. And obviously, if we wanted to just sum these, there's a lot of other ways we could do this too. But what we're doing here is I have this list L that has 1 and 3, 1, 5, 7, 9, 3, and then 4, 8, 12, 2. When I say reduce L, what it's going to do is it's going to sum this, then it's going to take the sum of that, and it's going to add this vector. Then it's going to take the sum of that and add this one, and then the sum of that and add this one. Okay, so this is an alternative way of looking at this, and this is kind of big, but basically it's like this, right? Sum L1, L2, okay, and then we're going to add L3 to that sum, and then we're going to add L4 to that sum. Okay, or slightly differently, this is the same thing, but we would say sum L1 and L2, store that in something called first sum. Then we're going to sum first sum and L3, and then we're going to sum second sum and L4 to get our final sum. Okay, so as it iterates through, it just collapses the list. So rather than returning each element, it collapses them. Does that make sense? So again, this is probably not the best use case. If I if I can come up with a better use case here soon, I will try to share that through an announcement or something. But as I was creating these slides, I just could not come up with that for some reason. Another use case, though, there's 2 others that I'll show. Let's say we had data frames like this. Okay, so we have these 3 different data frames, and I've just put them together in a list. So this one we have ID 1 to 3, and we have their scores, right? This one we have IDs 1 to 5, and we have treatment, what treatment they were in. And so this is just like creating some random 0s and 1s. And then this is, we have people, or ID 1, 3, 5, and 7, and we have some other thing, whatever, that's just some number, okay? So this is fairly common. It's not super, super common, but like if you're working with relational databases in particular, this can be fairly common where you have 4 or 5 different data sets and you just want to merge them all together, right? You want to merge all these data sets together at once. So we can do this by saying left join this one to this one, and then left join this one to this one, and then left join this one to this one, or full join this one to this one, whatever. You could do it in like 4 or 5 different lines of code. But you could also just put them all in a list like this, and then say reduce that list and join them. Okay, so here's an example where I say reduce this LDF, this thing, where you full join it. Okay, and I get a single data frame in return where it's joining this one, this one, this one to this one, right? And then it's taking the result of that join and joining it with this one. Okay, so this is doing basically 2 joins in a single loop to get this thing. Okay, you do have to be careful though about directionality. So if I say left join, right, left join, this is the first data set. So 1 through 3 is just going to carry on through, right? 1 through 3, so that means 4 and 5 in this data set are going to be dropped. And in this data set, 5 and 7 are going to be dropped. Okay, and you can see that over here. 1, 2, 3 is all we end up with, right? And then if we were able to look over here, we would see there's some missingness too. Okay, and if I do right join, and I know this is like over on top of each other, but I end up with just these ones, okay? Because I'm right joining these 2, so I would get 1 through 5. And then I'm right joining that result to this one, so I just end up with 1, 3, 5, and 7. Okay, so directionality matters. If you want to be really careful, you could do a full join like this. That'll keep everything. Sometimes, though, that becomes really unruly, so just be careful. All right, probably more common, at least in my experience, is you're working with a data frame, a bunch of data frames that are maybe split by something like, you know, whatever, grade or whatever. And you know, maybe they still have some different information, maybe they're all the same information, but you want to just find the rows of all of those data frames. So what you could do is just say reduce LDF2, where I'm just going to bind rows, okay? And that's just going to staple all of these together at once. Okay, and again, this will work whether you have 3 data sets or 15 data sets or whatever. Okay, all right, so there actually is a fair amount of PER that we haven't covered, even though we've spent a lot of time on it. I really think PER is a really good package. And like I mentioned at the start, there's some skepticism out there because map is sort of the primary function of PER, and it is exactly equivalent to lapply, basically, right? So if all you're using is map, there's no reason to use PER at all. But PER is nice because it has all these different additional functionalities, including safely, which I think is really nice, but also map df and type safe operations. So like map double and map int and map character, right? And so those are the same as vapply, but then you also have these parallel versions of them, which are a little bit more tricky to work with in base R. So like map2 CHR or Pmap CHR or whatever. Okay, so and again, like all of this is probably going to take a long time to get fully fluent with. And like even at the end of this class, I wouldn't expect many people would be fully fluent with all of this. But I would encourage you to continue to try to work with things. Anytime you're doing something that feels repetitive, just try to think to yourself, is there a way that I can reduce this problem to a single thing and then loop that through so I don't have to keep repeating myself, okay? So functional programming can be huge gains in efficiency and really allow you to do things that you wouldn't really otherwise be able to do a lot of the time. And looping is fundamental to that, right? Where the other part of that is writing functions. But even if all you can do is loops and you feel great working with loops, you're going to be way more powerful in your programming. Okay. All right. Any questions at all on today? Okay. So I know it's a lot, but this stuff I've mentioned a couple times, these looping variant things. If you look at your final project, I do ask you to use at least one of them in your final project somewhere. But generally, you know, modify is not that much different. Walk is not that much different. Safely is quite a bit different, but you don't have to use that one, right? So, and then reduce is quite a bit different also, but you don't have to use that one. So, okay. So as you're working on your midterm, please do get in touch with me if you're stuck, right? Don't suffer in silence. Get in touch with me so we can work through it. Okay. Alrighty, then I will see you next time when we begin functions. Okay.